Hi, Advanced Algebra 2B. So before you take these notes, if you were absent today, you're definitely going to make sure you want to check out the link that goes with the in-class section of what we did today in class. You're going to want to read through that before you take these notes to make sure that you understand some of the things I'm going to talk about next. Today in class we talked about normal distributions or bell curves. And one thing that I wanted to point out is there's a difference between the standard normal bell curve and a bell curve in real life. So the standard bell curve, if we're talking about something that's standard normal, its mean is 0 and its standard deviation is 1. And so that means the middle of the bell curve is 0, and then every time we want to go one standard deviation, we're just going 1 unit. Okay. So we talked today, for instance, if we go 1 standard deviation in each direction, then that captures 68% of all of our data points if something is distributed standard normal. However, we also talked about a real-life problem today. So like we talked about the temperature in Miami. And for us, I believe our mean was something like 75, maybe 75.5 degrees. For the sake of ease right now, I'm just going to make it 75. And our standard deviation was 5 degrees. And so for us, in this bell curve, we would make the middle 75. And then to go 1 standard deviation in both directions, instead of just going 1 unit in each direction, now we've got to go up 5 and down 5. So up 5 from 75 would be 80. So there would be 1 standard deviation above. And 1 standard deviation below would be 70. And so that would tell us that 68% of the time in Miami, the temperature is somewhere, the average temperature is between 70 and 80 in this situation. Okay. So make sure that you're paying attention between standard normal and real life normal. Now, we're going to end up having to use this standard normal because to find out anything other than 68, or today we also looked at 95%, 2 standard deviations away from the mean, and we looked at 3 standard deviations from the mean, to go anything other than whole units of standard deviations, we're going to have to use a standard normal table. So for that, let's consider a quote-unquote real problem. So, oh, by the way, in your notes, make sure that you get this written down for me, please. So scientists conducted an aerial survey, now aerial meaning they were in a plane, and they were counting the number of seals, so let's see, survey of a seal sanctuary, and recorded the number of seals they found. So if you can imagine, they're like flying over the California coast, and they're trying to get a count of how many seals they see. This obviously would be kind of tricky, right? Now, the number of seals observed were normally distributed, so they did this over several days. They kept going back and getting data points. And at the end of it, they found that there was a mean of 73 seals and a standard deviation of 14.1 seals. And the question that we want to answer is we want to find the probability that at most 50 seals, or another way to say that is 50 seals or less, were observed. So the first thing we're going to do is we're going to write down the mean and the standard deviation. So we've got 73, and standard deviation was 14.1. Okay. And now if we just think about this like we did today in class, that means if I were to sketch my bell curve, the middle of this bell curve is 73, and 1 standard deviation means that I'm going out 14.1 in each direction. So let's see, 73 plus 14 would be 87.1. And then in this direction, let's see, 73 minus 10 is 63. Minus 4 more is 59, minus 0.1 is 58.9. Can you tell I left my calculator at home? Okay, and so I could tell you where 68% of the data points lie. However, this question's asking, find the probability that at most 50 seals were observed. So really what they want to know, here's a second bell curve. Here's 73. Let's see, and 50 is way down here. And they want at most 50 or 50 or less. So they want to know what's the probability in this end of your bell curve. Well, to figure this out, we're going to have to find our z-score. So a z-score is sort of a standard score that compares a real-life situation to a standard normal. And for this z-score, we're going to use the formula x minus x bar over the standard deviation. Would you guys please make sure to box this in your notes? This is a formula we're going to use over and over again for this section. Okay. So if I want to find my z-score, let's see, I'm going to say z equals, I'm going to leave x where it is, oh, x is our data point, x is 50, sorry. X bar is the mean, so that's minus 73, and our standard deviation is 14.1. Oh shoot, Mrs. Lowney, you need a calculator. Okay, so hold on, I'm going to have to go into the computer to get a calculator real quick. I'm going to Google calculator. Okay, and on this calculator, I'm going to do 50 minus 73. Could probably do that part in my head. Negative 23. And then when I divide that by 14.1, let's see, I get negative 1.63. Okay, so this number is my z-score, negative 1.63, and now I need to look in my standard normal table. By the way, this is a table that you guys are going to get tomorrow. So I go into my standard normal table, and I look at the picture, and I notice over here, this is shaded to the left, which is the same thing I'm trying to find. I'm trying to find shaded to the left. And I see up in the corner, it says z. Now I want to find it when z is equal to negative 1.63. Notice here your z's are all getting bigger. Like there's 1.6, right? But I want a negative 1.63. And so I'm going to flip the paper over. The paper you guys get tomorrow is going to be two-sided. So z equals negative 1.63. All right, so now I've got some negative numbers. I'm scrolling down on this side of the paper, and I know you guys probably can't read this real well, till I get to negative 1.6. And then on the top of the paper, I need to get that 3. So I go over till I get 0.03. And that means if I come down my table and across, real careful, the score that goes with this is 0.0516. That's the number that goes with negative 1.6 and 0.03. Okay. Now, this is a decimal, but it's really a hidden percentage. So if I have 0.0516, I move the decimal place 2 over, and this is really 5.16%. It's like multiplying by 100. And so back on my paper for my answer, what percent goes here? This is 5.16% is the probability or the chance that 50 or fewer seals were observed. So the last bit on your notes that I want you to write is the probability, you're going to rewrite the question, that fewer than 50 seals were observed is 5.16%. All right, make sure that you have everything on my paper written down on your paper for your notes for tonight. And then, you know, it might not be a terrible idea to rewatch the end of the video. That might have went kind of quick, or maybe to pause it. And we will practice this tomorrow in class. All right, guys, have a good night.